Welcome to Lecture 8 of How to Read and Do Proofs. Okay, the next two proof techniques that you're going to learn require that you be able to take the negation of a statement. In other words, to write what it means to say that a statement is not true. So today what we're going to do is learn the rules for writing the negations of statements. So, for example, the real number x is greater than 0. What does it mean to say that that is not true? X is less than or equal to 0. Unfortunately, it's not always that easy to write the negation of a statement. So now what we're going to do is learn how to take the negation of statements that contain certain keywords. So for example, if the statement that you're trying to take the negation of already contains the word not in it, the not of that statement simply becomes the original statement C. So for example, if A is the statement y is not a root of f of x, what does it mean to say that that is not true? Then y is a root of f of x. And this not here cancels that not there. Let's take this example here. R is irrational. That means R is not rational. What does it mean to say that this statement is not true? R is rational. So the not of a not cancels, and you just get the original statement back. All right, here's another rule for taking the negation of a statement. When the statement you're taking the negation of has the keyword and in it, as in not C and D, the negation becomes not C or not D. Notice how the and becomes an or. Let's take an example. Suppose A is the statement x is greater than or equal to 3 and y is less than 2. What is the negation of that statement? Not A is x is less than 3 or y is greater than or equal to 2. Okay, just as the word and changes to or when you take the negation, so the word or changes to and. So not C or D becomes not C and not D. For example, let's suppose A, B, and C are integers, and suppose I said to you, either A divides B or A divides C. What does it mean to say that this statement is not true?
A does not divide B and A does not divide C.
Exactly. A does not divide B and A does not divide C. Notice the or changes to an and you put the word not in front of A divides B and A divides C. A more challenging situation arises when you're trying to take the negation of a statement that contains quantifiers. So as an example, suppose that you're trying to show that there is an object with a certain property such that something happens. What does it mean to say that that statement is not true?
For every object with the certain property, something does not happen.
Exactly. So the not of B is for every object with a certain property, the something does not happen. And what you can see here is that the quantifier there is changes to a for all. Let's find the negation of the statement, there is an angle t between 0 and pi over 4 such that cosine of t is less than sine of t. Let's identify the objects, the certain property, and the something that happens. What's the object here?
There is an angle t.
An angle t is the object. The certain property is t is between 0 and pi over 4. And the something that happens is cosine of t less than sine of t. So the negation of this statement, that is not A, is, watch how this is done, the there is becomes a for all. The object with the certain property does not change. And then you take the not of the something that happens. What does it mean to say that it is not true that cosine of t is less than sine t? It means that cosine of t is greater than or equal to sine t. So first, again, notice that the quantifier there is changes to for all, and the words such that are replaced with a comma. This is good grammar. Let's do another example. Suppose that you want to show that for every object with a certain property, something happens. What does it mean to say that this is not true? It is not true that for every object with a certain property, something happens.
There is an object with a certain property such that something does not happen.
Exactly. There is an object with a certain property such that the something does not happen. And again, you can see the quantifier for all changes to its opposite. There is. Let's try one more example. Let's find the negation of the statement A for all real numbers x greater than or equal to 2 x squared plus x minus 6 is non-negative. So again, we need to identify the objects, the certain property, and the something that happens. And now, what is not A? Well, the for all changes to there is. The object with a certain property does not change. And then you take the negation of the something that happens. It is not true that x squared plus x minus 6 is greater than or equal to 0, or in other words, x squared plus x minus 6 is negative. Notice that the for all changes to there is, and the comma changes to the words such that. Let's make a summary of finding the not of a statement with a quantifier. Here are the rules. Step 1, put the word not in front of the entire statement. Step 2, if you see a quantifier that appears to the right of the word not, then here's what you have to do. You have to move the word not from left to right through the quantifier. As you do so, change the quantifier to its opposite. A for all becomes there is, and a there is becomes for all. Do not change the object or the certain property. And now, the word not is just in front of the something that happens, and you have to incorporate that word not into the something that happens, thus eliminating the word not. So when the statement you are taking the not of has nested quantifiers, you simply repeat step 2 for each quantifier from left to right. Let's take a look at an example. Let's find the not of this statement right here. So let's follow the steps. The first step is to put the word not in front of the entire statement. Now let's work with the quantifier for all. That's the first quantifier from the left. Pick up the word not, move it from left to right, and put it right before the something that happens. That's step 2. As you do that, the quantifier for all changes to there is. The certain property does not change, and now you see the word not in front of the something that happens. Now you see another quantifier. Again, identify the objects, the certain property, and the something that happens. Move the word not from left to right and put it right in front of the something that happens. As you do so, change the quantifier there is to its opposite for all. There is becomes a for all. The object with a certain property does not change. And now you have the word not in front of the something that happens. And now you don't see any more quantifiers, so you can incorporate the word not into the statement here. What does it mean to say that it is not true that x squared plus y squared is less than or equal to 1? X squared plus y squared is greater than 1. And this is the negation of the original statement. Let's do another example. Let's find the negation of there is a real number m strictly positive such that for every element x in S, absolute value of x is less than m. So again, according to step 1, you put the word not in front of the entire statement, and then you process the quantifiers from left to right. Here the first quantifier that we see is there is, so you have to identify the objects, the certain property, and the something that happens. Now move the word not from left to right and put it right in front of the something that happens for the quantifier there is. As you move that word not from left to right, change the quantifier there is to for all. For every real number m strictly positive, it is not true that for all elements x in S, absolute value of x less than m. Notice that the objects with a certain property did not change. Now we're looking at the not of this statement, and we see a quantifier for all. So again, you're going to pick up the word not, move it from left to right, and put it in front of the something that happens. As you move the word not from left to right, change the quantifier for all to its opposite. There is. Notice the object with a certain property does not change, and now the word not is in front of absolute value of x less than m. And finally, since I don't see any more quantifiers, you can incorporate the word not directly into this statement. What does it mean to say that it is not true that the absolute value of x is less than m? Absolute value of x is greater than or equal to m. And this now becomes the negation of the original statement. So it doesn't matter how many quantifiers you have. The key to processing quantifiers is to work with them from left to right. All right, now let's look at the negation of the statement A implies B. What does it mean to say that A implies B is not true? When is the statement A implies B not true?
When A is true and B is false.
That is correct. From the truth table, the statement A implies B is true in all cases except when A is true and B is false. If you want to prove that the statement A implies B is false, then from row 2, what you need to show is that A is true and B is false. Suppose now A and B are conditional statements that depend on the value of a variable, say x. That means you want to show that for all x, A of x implies B of x. If you want to show that this statement is not true, here is the negation. It is not true that for all x, A of x implies B of x. There is a value of x for which it is not true that A of x implies B of x. And now you can incorporate the not into this statement. Not S is, there is a value of x such that A of x is true and B of x is false. So if you want to show that this statement here is not true, you have to show that there is a value of x for which A of x is true and B of x is false. What proof technique would you use to show that this is true?
The construction method?
The construction method, because you see the keywords there is. So that's exactly what we're going to do here. When you produce a specific value of x for which A of x is true and B of x is false, that's what we call a counterexample to the statement that for all x, A of x implies B of x. So let's take a look at an example. If x is strictly positive, then the log base 10 of x is also strictly positive. To show that this statement is not true, we have to produce a value of x for which the hypothesis is true, A of x is true. We need a value of x for which x is positive, and log base 10 of x is not positive. Can you give me a value of x that is positive, but for which the log base 10 of x is not positive?
0.1.
0.1 will do just fine, because when x is 0.1, that's positive, but the log base 10 of 0.1 is minus 1, and that's negative. X equals 0.1 is a counterexample to this implication. Let's do another example. Let's look at the statement, if n is a positive integer, then n cubed is greater than or equal to n factorial, n times n minus 1 times n minus 2 all the way down to 1. We want to produce a counterexample to this. That means we need a value of n that is a positive integer, but for which n cubed is less than n factorial. What value of n will do that? Let's try 1. When n is 1, 1 cubed is 1, and 1 factorial is 1. So that's true. We need to try different values of n to find a value for n that is positive, and at the same time we need n cubed to be less than n factorial. So this will be a trial and error process. So it turns out that n equals 6 is a positive integer, and yet 6 cubed is 216, while 6 factorial is 720. 216 is less than 720. This is a counterexample. Let's summarize the rules for finding the negation of a statement. First of all, to find the negation of a statement that contains keywords, here are the rules. If your statement already contains the word no or not, the not of that statement eliminates the not in your statement. So not C becomes C. The not of the statement C and D becomes not C or not D. The and changes to an or. Likewise, the not of C or D becomes not C and not D. The or changes to an and. Just as the words and or change, so the quantifiers change. The not of for every object with a certain property something happens becomes there is an object with a certain property such that the something does not happen. Likewise, the not of there is an object with a certain property such that something happens becomes for every object with a certain property something does not happen. Not A implies B is true when A is true and B is false. That gives us an understanding of a counterexample. A counterexample consists of values for the variables that make the hypothesis A true and the conclusion B false. That completes this lecture.